Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem minimum platforms. So we are just given the arrival array and departure array and we have to find the minimum number of platforms needed so that no train waits. So we are just given the arrival array which tells us at what time the train is arrived, and the departure array tells us the ith train is departing at what time, and we just have to tell how many minimum number of platforms do we need such that a platform contains only one train at a time and no train has to wait. So we need to tell how many number of platforms, minimum number of platforms do we need. So first of all we can see that this train, from this array a train is coming at, let's say, this 900. In the note it is given that this 900 is in 24-hour format. So this 900 is, it's like just 9 p.m. and 910 is like 9:10. All right, so let's say our train arrives at 9 and 9 leaves at 9:10. So we need one platform for this. So let's say we have this platform, and this platform is needed for this train. Now this next train comes at 9:40 which is after 9:10, and we know that at 9:40 the train, the platform is now empty. So we can say that this train can come here. So all right, so this train can come here easily, and this train leaves at 12. Now when a train comes at 9:50, we need another platform for this train, because when it will come, a train will be already standing at the platform. This train will be already standing. Now when a train comes at 11, again we need a different platform. So we need a different platform for this. So similarly checking all of the trains, but we know that these arrays are not sorted. So we will get difficulty in checking if the, let's say we are checking this platform is empty or not. What if this platform was empty already? So we need to sort them. So what I will do, after sorting, we can easily make the observation what do we need actually. So let's sort them, and after sorting this will become, so these are already sorted, and the arrival array is already sorted, and the departure array I have to sort. So this will become 1120. So I should write the departure array. So this will be like 910 and 1120, 1130, 1200, 1900 and 2000. Now I should delete this. So we have these sorted arrival and departure arrays. Now what I will do, I will just check that if a train is coming. So if a train is coming at 9, we need a platform. Suppose we are here, our I pointer is here and J pointer is here. So when a train is coming, we need a platform when a train is coming. So we will say +1 if our arrival is first. All right, and then I will check the next one. I will move this I and I will check 940 is greater or 910 is greater. I mean that next train is arriving first or the previous train is departing first. So if the next train is arriving first, so I will say that I need a new platform. But if the is next train, I can see before the arrival of any train, a train is departing. So I can say I can reduce my platforms. I mean my platform is now free. So in this case, 910 is less than 940. So it means a train is departing. So I can say number of platforms can be reduced. So now I will move J. Now I will check among I and J that 940 is less. It means a train is coming. So I need a platform. I will increase it by 1. So if I maintain the count, so I should delete this and I maintain the count. Initially it was 0, and when I saw this arrival was first, so I need a new platform. Then I checked that departure was there, so now again it will become 0. Now again I check that arrival is there, now it will become again 1. Now this will move, 950 or 1120. So 950, it means a train is coming, we should increase. And then again a train is coming, we should increase. Then 1120, which among them is happening first? Arrival is happening first or departure is happening first? We can see departure is less, so we need uh, to reduce the number of platforms because a train is leaving now. Platform is becoming empty. Now 1130 or 1500? 1130. So we reduce it and move J. Now again we reduce it, move J. Again I arrival is there, increase. Now again increase. Now it will go out of bound. So now we can see our maximum count here is 3, and this will be our answer because our count is storing how many number of platforms do we need at this time, at the current time. So at a time we need 3 platforms, so the answer is also 3. So this was the logic that we will just sort array and departure array, arrival and departure array, and we will check if a train is arriving first, we will increase our platform by 1. If the train is departing, we will reduce the number of platforms by 1. So this is the logic. So if I implement this, so first of all what I said that I will sort them. So I will sort them arr dot begin comma arr dot end, and similarly I will do this for departure array, and then what I said, I will maintain a count variable that will count number of platforms at the current time, and also I will maintain a max count because I need to tell the minimum number of platforms needed. Alright, so initially it is 0, and yes, the size of this is arrow dot size, and now iterating from, and let's take 2 pointers because they both are different arrays. So I would say that I'm taking 2 pointers I and j. Now while I is less than n and j is also less than n, so I will say that if arr of I is less than equal to departure of j, it means that a train is arriving first. Alright, so I will say that increase my count, and my max count I will update later, but I will increase my count, and I will move I pointer also. And if a train is leaving, it means that departure is happening, so I will just reduce my count and move J ahead. And before I am moving ahead, I would just update my max count, and at last I will simply return the max count. Now if I check I'm making any mistakes, so I think I'm good to go. So if I submit this and check if we are able to pass the all the test cases, so we can see that we have solved this problem successfully now. And if I tell you the time and space complexity, so we can see that this sorting is taking n log n, and this while loop is taking linear time. So we can see overall time complexity is big O of n log n. Alright, and space complexity, time complexity is big O of n log n plus n, but overall after calculation the maximum time complexity will be taken, so this will be big O of n log n. And space complexity, we can see we are not using any extra space, so space complexity is big O of 1. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.